Okay, welcome to video 6.5. Here we're going to talk about exponential application word problems. So let's start by looking at this first one. An oil spill is spreading such that its area is given by the exponential function a of t equals 250 times 1.15 to the t power, where a is the area in square feet and t is the time that has elapsed in days. How large was the oil spill initially? Well, I think that word initially is very important here, because initially, to me, that means what is the initial value? And I know that just by looking at the exponential equation here. So if I look there, I see the number 250, and since it's asking me how big it was, and it says A is the area in square feet, I'm going to say 250 square feet, or feet squared, either way is okay. So square feet. What percent is the oil spill increasing each day? Well, remember we talked about this a little bit in class. When we have this increasing, it's the 1 plus the rate. So that 1 plus r is what the b value represents since it's an exponential growth. So I know that the b value, by looking at my equation, is 1.15. So I could put that in place of b, and that equals 1 plus the rate. So in order to solve for the rate, I could subtract 1 from both sides, and then that would give me my r value. So I can say that the r value here is 0.15. You can also think of it as, since it's 1.15, that is 115%. The 100% is already, that's like the 250 just being that again. So the 15% is the additional percentage there. So that must be the rate. So by what percent is the oil spill increasing? Well, I found my R value, but that's not the final answer because they want to know what percent. So I have to say 15%. And that's the exponential growth here. That's what's happening in this function. It's an exponential growth of 15%. Okay, let's try another one together. A population of 50 fruit flies is increasing at a rate of 6% per day. Which of the following is closest to the number of days it will take for the fruit fly population to double? Well, I think that in order to do this, we should write our exponential equation. I'm going to help you with that. But then I'm going to leave it up to you to then find which one is the right answer by using the exponential function we're going to write. I'm just going to use f of x, but remember that you could use like p of f or whatever you want. They didn't specify here, so I can use whatever I want. I could even just say y equals. So the population, well, initially it's 50, so I'm going to put that in as my a value. It's an exponential growth. I know that because it's increasing at a rate of 5% or 6%. So that rate of 6% increase, that's what tells me that this is an exponential, and more specifically an exponential growth. And I know that it's 50 initially. So my function then can be finished off by putting in 1 plus, since it's a growth, and again I know that because it says it's increasing. I can't put 6% in there, so I have to change that to a decimal, so 0.06 to the, and I can say x for now because that's what I have in place of f of x, so I didn't use anything special there. All right, then we can, if you want, you can simplify this to be that f of x equals 50 times the 1.06 to the x power, and that's more specifically if you like to think of it as, okay, well, it's a 6% increase, that means it's 106% altogether, and that's where that decimal comes from then. Okay, so which is the closest number of days it will take for the fruit fly population to double? So that means that we're looking for the f of x, the population, to now be 100. So then you would have to either put this in where y equals and check the table to find out when our y value finally goes over 100, or you can plug in each answer in place of x and see which one you get. Okay, we'll finish that up tomorrow. Have a good night.